It is not okay to hang a 30 kVA transformer above a suspended ceiling for several reasons. Firstly, weight is a critical factor. A 30 kVA transformer is heavy, typically weighing over 300 pounds, which is approximately 136 kilograms. A suspended ceiling is generally not designed to bear this weight. The structural integrity of the suspended ceiling is compromised, and it may collapse under the load of the transformer. Secondly, heat dissipation poses another significant challenge. Transformers generate heat during operation. This heat needs to be dissipated into the surrounding air to prevent overheating. A suspended ceiling restricts airflow, thus preventing the transformer from cooling efficiently. Inadequate cooling can lead to transformer damage, reduced lifespan, and an increased risk of fire. Thirdly, accessibility is a major concern. Transformers require regular maintenance and inspection to ensure proper operation and identify potential issues. Hanging a transformer above a suspended ceiling makes it difficult to access for these tasks. Maintenance personnel may encounter difficulties in reaching the transformer, leading to delays or neglected maintenance. Fourthly, fire safety is paramount. Transformers contain flammable materials such as oil or coolant, which can pose a fire hazard. In the event of a fire, a transformer hanging above a suspended ceiling could spread flames and smoke throughout the building more rapidly. The suspended ceiling could act as a conduit, allowing the fire to spread to other areas and endangering occupants. Fifthly, building codes often prohibit the installation of heavy equipment such as transformers above suspended ceilings. These regulations are in place for safety and accessibility reasons. Compliance with building codes is essential to ensure the safety of the building and its occupants. Proper installation of a transformer is crucial to ensure safe and reliable operation. Transformers should be installed on a solid, level surface with adequate ventilation. Here are recommended installation guidelines. 1. Install the transformer in a well-ventilated area with at least 12 inches of clearance on all sides to allow for proper airflow and heat dissipation. 2. Mount the transformer securely using bolts or other appropriate hardware to prevent it from tipping or falling. 3. Ensure there is sufficient airflow around the transformer to facilitate heat dissipation and prevent overheating. 4. Avoid installing the transformer above areas with combustibles or flammable materials to reduce the risk of fire. By following these guidelines, electrical professionals can ensure the safe and efficient operation of transformers in various applications. Remember, safety should always be the top priority when working with electrical equipment. Always consult with qualified professionals and adhere to all applicable codes and regulations. Transformers play a vital role in electrical power distribution systems. They are used to step up or step down voltage levels to match the requirements of different equipment and loads. Understanding the principles of transformer operation, including voltage transformation, current transformation, and power transfer, is essential for electrical engineers and technicians. Transformers consist of 2 or more coils of wire wound around a common core. The primary coil is connected to the input voltage source, while the secondary coil is connected to the load. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. When an alternating current flows through the primary coil, it creates a magnetic field that induces a voltage in the secondary coil. The magnitude of the induced voltage depends on the turns ratio and the input voltage. Transformers are designed to operate at specific voltage and current levels. Exceeding these limits can lead to overheating, insulation breakdown, and transformer failure. Proper sizing of transformers is crucial to ensure reliable operation and prevent damage. Transformers are used in a wide range of applications, including power transmission and distribution, industrial equipment, and electronic devices. In power transmission systems, transformers are used to step up the voltage for long-distance transmission and then step down the voltage for distribution to local customers. In industrial equipment, transformers are used to provide the required voltage levels for motors, welders, and other machinery. In electronic devices, transformers are used to isolate circuits, provide voltage conversion, and match impedances. Transformers are available in various types and sizes depending on the application. Common types of transformers include power transformers, distribution transformers, isolation transformers, and autotransformers. Power transformers are used in high-voltage power transmission systems. Distribution transformers are used in local power distribution networks. Isolation transformers are used to isolate circuits and provide safety. Autotransformers use a single coil for both the primary and secondary windings, making them more efficient and compact. Transformer efficiency is an important consideration in electrical system design. Transformer losses include core losses, copper losses, and stray losses. Core losses are caused by hysteresis and eddy currents in the transformer core. Copper losses are caused by the resistance of the transformer windings. Stray losses are caused by leakage flux and other factors. High-efficiency transformers can reduce energy consumption and save money over the long term. Transformer maintenance is essential to ensure reliable operation and prevent failures. Regular maintenance tasks include inspecting the transformer for leaks, corrosion, and damage, checking the oil level and condition, testing the insulation resistance, and tightening connections. Proper maintenance can extend the lifespan of a transformer and prevent costly downtime. Transformer protection is also important to prevent damage from overloads, short circuits, and other faults. Transformer protection devices include fuses, circuit breakers, and protective relays. These devices are designed to detect abnormal conditions and isolate the transformer from the power system to prevent damage. Transformer grounding is necessary to ensure safety and prevent electrical shock hazards. Transformers should be grounded according to applicable codes and standards. Proper grounding provides a low impedance path for fault currents, reducing the risk of electrical shock and equipment damage. In summary, transformers are essential components of electrical power systems. They are used to step up or step down voltage levels, isolate circuits, and provide power to various loads. Understanding the principles of transformer operation, proper installation techniques, and maintenance procedures is crucial for electrical engineers and technicians. By following best practices, electrical professionals can ensure the safe, reliable, and efficient operation of transformers in a wide range of applications. Remember to always prioritize safety when working with electrical equipment and consult with qualified professionals when needed. The information provided in this narration is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer for specific electrical installation or maintenance requirements. Working with electricity can be dangerous, and it is essential to take all necessary precautions to prevent accidents and injuries. Always follow applicable codes and regulations when working with electrical equipment. Transformers are a critical part of modern electrical infrastructure, enabling the efficient transmission and distribution of electrical power over long distances. Their ability to step up voltage for transmission and step down voltage for distribution makes them indispensable in providing reliable electricity to homes, businesses, and industries. As technology advances, transformers are becoming more efficient, more compact, and more reliable. These improvements are helping to reduce energy consumption, lower costs, and improve the overall performance of electrical power systems. The future of transformers is bright, with ongoing research and development focused on creating even more advanced and sustainable transformer technologies. These innovations will play a key role in meeting the growing demand for electricity while minimizing the environmental impact of power generation and distribution. In addition to their traditional applications, transformers are also being used in new and emerging technologies, such as renewable energy systems, electric vehicles, and smart grids. These applications are driving innovation and creating new opportunities for transformer manufacturers and electrical engineers. As the world transitions to a more sustainable energy future, transformers will continue to play a vital role in enabling the integration of renewable energy sources, improving energy efficiency, and reducing greenhouse gas emissions. Their versatility, reliability, and efficiency make them an essential component of the modern energy landscape. The proper selection, installation, and maintenance of transformers are critical to ensuring the safe and reliable operation of electrical power systems. By following best practices and staying up to date with the latest technologies and standards, electrical professionals can help to maximize the performance and longevity of transformers and contribute to a more sustainable energy future. Understanding transformer characteristics such as voltage rating, kVA rating, impedance, and insulation class is essential for proper selection and application. These parameters determine the transformer's ability to handle voltage and current, withstand short circuits, and operate safely in various environmental conditions. Careful consideration of these factors is crucial to ensure that the transformer is appropriately sized and matched to the specific application requirements. Furthermore, proper installation techniques, such as using appropriate mounting hardware, providing adequate ventilation, and ensuring proper grounding, are essential to prevent overheating, electrical shock hazards, and other safety risks. Adhering to these best practices can help to extend the lifespan of the transformer and ensure its reliable operation over many years. Regular maintenance, including inspecting for leaks, corrosion and damage, checking oil levels and condition, and testing insulation resistance, is also crucial to identify potential problems early and prevent costly downtime. By implementing a proactive maintenance program, electrical professionals can help to keep transformers operating at peak performance and minimize the risk of unexpected failures. In conclusion, transformers are a vital component of modern electrical power systems, enabling the efficient transmission and distribution of electricity to homes, businesses, and industries. Their versatility, reliability, and efficiency make them an essential part of the energy landscape. By understanding their principles of operation, following best practices for installation and maintenance, and staying up to date with the latest technologies and standards, electrical professionals can help to ensure the safe, reliable, and sustainable operation of transformers and contribute to a more secure energy future. It's important to remember that working with electrical equipment can be dangerous, and it is essential to take all necessary precautions to prevent accidents and injuries. Always consult with qualified professionals and adhere to all applicable codes and regulations when working with transformers or other electrical equipment.